China's new solid-state EV is destroying global markets because it attacks every weakness the car industry still depends on. It promises over 1,000 kilometers of range, charging in under 10 minutes, lower battery costs, and safer performance than today's EVs. That means older electric cars, petrol cars, Western factories, and even suppliers all come under pressure at once. Tesla, Volkswagen, Ford, and Toyota are now facing a market where China controls the batteries, the supply chain, and the next technology wave. But the real question is, how did China build this lead before the world noticed? China's solid-state EV does not just challenge today's cars, it attacks the basic limits behind them. Current EVs still fight range anxiety, long charging times, battery fire fears, and high prices. A Chinese EV with 1,000 kilometers range, under 10-minute charging, and lower cost would make many older EVs and petrol cars feel outdated at the same time. Damage spreads across 4 markets at once. Buyers move toward cheaper, longer-range Chinese EVs. Western factories lose production volume. Parts suppliers lose orders as Chinese companies build more components in-house. Investors start lowering the value of car companies that no longer look competitive. This is not one problem. It hits consumers, factories, suppliers, and stock markets together. Financial pressure is already visible. Volkswagen lost €2.2 billion in net profit in 2023. Ford's EV division lost about $4.5 billion in the same year, equal to roughly $3,000 on every EV sold. GM delayed its EV targets more than once. These numbers show strain before solid-state batteries have even reached full mass production. Human cost reaches far beyond boardrooms. More than 8 million people work directly in auto manufacturing across Germany, France, Italy, and the United States. Every lost market share point can mean fewer shifts, slower factories, weaker suppliers, and smaller paychecks. The EV fight is not only about brands, it is about jobs tied to entire industrial regions. Destroys everything means the market reaches a tipping point. When one car removes the biggest objections, range, charging time, safety, and cost, buyers do not wait forever. Markets in Southeast Asia, Latin America, and parts of Europe already show Chinese EVs gaining ground fast. Solid-state batteries could turn that shift into a global reset. The electric car did not begin in China. Early versions were built in the West long before modern EVs existed. Scottish inventor Robert Anderson created one of the first practical electric vehicles in the 1830s, before petrol cars became dominant. By 1899, drivers like Camille Janazzi in France were pushing electric cars past 100 kilometers per hour, years before Henry Ford turned cars into a mass product. The modern EV battery also came from outside China. The key lithium-ion chemistry was developed by John Goodenough at Oxford University in 1980. Sony commercialized it in Japan in 1991, and researchers across America, Europe, and Japan improved it for nearly 20 years. This was the battery foundation for almost every modern electric car, but China was not yet leading that work. General Motors had a major EV lead with the EV1 in 1996. It was leased to drivers in California, offered around 160 kilometers of range, used regenerative braking, and had its own fast charging system. Then, GM cancelled the program in 2003, recalled the cars, and crushed most of them. China did not stop that project. The decision came from inside the Western auto industry itself. Tesla revived the EV dream in 2003 with American engineers, American investors, and a Silicon Valley mindset. The Roadster arrived in 2008 and proved that electric cars could be fast, desirable, and profitable. For the next 10 years, the world treated EVs as a Western technology story, while China was still seen mainly as a place assembling cars and parts for brands like Volkswagen and Toyota. China's rise began because the West invented the electric car, then slowed down when the hard investment was needed. Western companies had the history, the science, and the first big chances, but they kept protecting combustion engines. China stayed focused, funded the supply chain, and built around batteries. The solid-state EV threat is not just about China moving fast. It is about the West leaving the door open. Back in 1990, China's car industry was still far behind the rest of the world. The country produced fewer than 500,000 vehicles a year, and most of them were trucks or buses. Passenger cars were rare, and many came from joint ventures with companies like Volkswagen and Toyota. For Chinese buyers with money, owning a Chinese car usually meant driving foreign engineering assembled inside China. Everything started shifting after China joined the World Trade Organization in 2001. Opening the market exposed how far local companies were behind in engines, transmissions, factory quality, and brand reputation. Trying to catch Germany, Japan, and the United States in combustion engines would have meant chasing decades of experience. Instead of fighting on the old road, China focused on the technology expected to replace it: electric vehicles. A major turning point came in 2009. China officially labeled EVs a strategic industry and backed the plan with around $230 billion spread across 15 years. State banks supported battery companies, government fleets were pushed toward EV purchases, and universities worked closely with manufacturers. Research moved from labs into factories much faster than in many Western systems. Scale became China's biggest advantage. With a population near 1.4 billion, Chinese EV makers had room to experiment at huge volume. Companies could release cars, collect feedback, improve software, lower costs, and fix battery problems while selling millions of vehicles inside their own country. Every sale added factory experience and real-world driving data that competitors outside China could not easily match. By 2023, the results were impossible to ignore. In only 33 years, China went from a weak automotive market to the world's largest EV market and the world's biggest vehicle producer overall. Chinese companies were now leading in batteries, supply chains, and EV manufacturing scale, while many Western automakers were still heavily tied to the combustion engine business they had dominated for over a century. Every EV on sale today still depends on lithium-ion battery technology, first commercialized in 1991. That includes Tesla, BMW, Hyundai, Rivian, and even BYD's current models. For more than 33 years, the industry has improved this battery step by step, but the basic system stayed the same. Solid state does not simply improve that old system, it replaces the weakest part inside it. The liquid electrolyte is the main limit inside a normal EV battery. It helps ions move between two electrodes, but it also creates problems. At high temperatures, it can become flammable. In freezing weather, it loses performance, causing around 30% to 40% winter range loss. It also slows charging, which is why many EVs still need 25 to 45 minutes at fast chargers. A solid-state battery removes that liquid and uses a solid electrolyte made from ceramic, glass, or polymer. This single change makes the battery safer, improves cold weather performance, and allows faster ion movement. It also lets more energy fit into the same weight. The best lithium-ion cells sit around 250 watt-hours per kilogram, while solid-state designs are targeting around 500 watt-hours per kilogram. That means longer range without making the car heavier. China's battery makers are already using these numbers to pressure the market. CATL announced a condensed battery in April 2023, claiming 500 watt-hours per kilogram. NIO announced a solid-state capable pack in 2023, claiming up to 1,000 kilometers, or about 620 miles, of range. Tesla's longest-range Model S was around 405 miles at that time. That is not a small upgrade. It is a different class of EV. Solid-state technology threatens current EVs because it removes the reasons many buyers hesitate. Range anxiety, long charging, winter loss, and fire risk all become weaker arguments. When a battery charges near 0 to 80% in under 10 minutes and travels close to 1,000 kilometers, older lithium-ion EVs start looking like the previous generation. For Western brands built around today's battery platforms, that is the real danger. A company most drivers have never heard of now sits at the center of the global EV industry. CATL, short for Contemporary Amperex Technology Company, was founded in 2011 in Ningde, located in Fujian, China. Within just 11 years, it grew into the world's largest EV battery maker. By 2022, CATL controlled around 32% of the global EV battery market, giving it enormous influence over how the electric car industry moves. Many Western car brands now rely on CATL, whether buyers realize it or not. Companies like Ford, BMW, Toyota, and Volkswagen have all sourced battery cells from the Chinese giant. A vehicle may carry an American, German, or Japanese badge, but the battery powering it can still come from CATL. Without those cells, production lines for many EV models would slow down or stop completely. Battery performance helped push CATL into this position. In 2022, the company introduced its Qilin battery, claiming around 255 watt-hours per kilogram energy density and close to 1,000 kilometers of driving range using advanced lithium-ion technology. Many Western automakers expected solid-state batteries to deliver numbers like that years later. CATL was already reaching similar performance using technology it could manufacture at large scale. Manufacturing design gave the company another advantage. CATL developed cell-to-body integration, where battery cells become part of the vehicle structure instead of sitting inside a separate heavy battery pack. This reduces weight, improves body strength, and creates more room for energy storage. Chinese EV companies started moving these systems into production, while many Western automakers were still refining older battery layouts. Pressure on the industry increased again in April 2023, when CATL announced its condensed battery targeting around 500 watt-hours per kilogram energy density. The company said the battery could power both EVs and commercial aircraft. Coming from a manufacturer already supplying roughly 1/3 of the world's EV batteries, the announcement carried weight far beyond a normal product launch. It showed how quickly battery technology, and the companies controlling it, were moving ahead. A major shift hit the EV market in Q4 2023. BYD delivered about 526,000 pure electric cars, while Tesla delivered 484,507. For more than 10 years, Tesla shaped the modern EV industry with software, superchargers, gigafactories, and high-performance EVs. Then, a Chinese company many analysts dismissed in 2019 moved ahead on global deliveries. Sales numbers caught attention, but profit margins revealed the deeper story. In 2023, BYD's vehicle gross margin was around 23%, while Tesla's stood near 17.6%. BYD was often selling cars roughly $15,000 cheaper than similar Tesla models, and still keeping stronger profits. Lower prices with stronger margins usually point to factory efficiency and supply chain control. Control over production gave the company a major advantage. BYD manufactures its own battery cells, semiconductors, steel, glass, and seat parts. Most Western automakers still depend heavily on outside suppliers for many of those components. When lithium prices surged in 2022, BYD absorbed more of the pressure internally. During the 2021 global chip shortage, its internal semiconductor production helped factories keep moving. Price competition became clearer in markets with fewer tariff barriers. A BYD Seal priced near €30,000 could compete directly with a Tesla Model 3, while offering strong range, charging speed, and interior quality. Buyers still care about brand image and software, but many care more about saving around €15,000 on the final purchase. China's EV growth stopped looking temporary after this crossover moment. Tesla still held global recognition, strong software systems, and loyal customers, but BYD showed how manufacturing scale and supply chain control could shift the market. The solid-state announcements that came next suggested the industry was already moving toward another major change. Toyota spent more than 15 years building one of the world's biggest solid-state battery patent collections. Starting in the early 2000s, the company registered patents covering electrolytes, battery structures, production methods, and cell layouts. By normal industry standards, Toyota looked like the company closest to owning the future of solid-state EV technology. The real problem appeared during manufacturing. Toyota's scientists solved many chemistry questions, but mass production became the barrier. Solid ceramic electrolytes can crack during charging and discharging because battery materials expand and shrink over time. These tiny fractures slowly damage the cell. Building one successful battery in a lab is possible. Producing thousands every day with ceramic layers thinner than a human hair is a much harder challenge. Toyota's launch schedule kept moving further back. The company first aimed for 2020, then shifted toward 2022, later 2025, and now around 2027 to 2028. During the same period, Chinese companies like CATL and BYD used a different strategy. Instead of waiting for perfect all-solid-state batteries, they pushed semi-solid and hybrid systems first, gaining many of the same benefits while avoiding the hardest production problems. Western battery startups faced similar struggles. QuantumScape, backed by Volkswagen, received major investment and showed strong lab results, but manufacturing yields stayed too low for large-scale production. Its stock price later fell more than 80% from its 2020 peak. Solid Power, supported by BMW and Ford, followed a similar path with promising research, but slower factory progress and repeated timeline changes. China's advantage came from solving the production path differently. Companies like CATL and BYD did not need to copy Toyota's exact battery design. They built alternative systems that could reach factories sooner and still improve range, charging speed, and safety. Toyota owned many of the patents, but Chinese manufacturers focused on building products that could move from the lab into real vehicles faster. Solid-state EV competition is not only about better batteries or cheaper cars. The real control sits inside lithium refineries, cobalt plants, and graphite processing sites. Many of these are tied to China, and that gives Chinese battery makers power before the first solid-state car even reaches a showroom. The fight is being decided deep inside the materials chain. Lithium processing shows the lock clearly. Raw lithium can come from Australia, Chile, and Argentina, but it must be refined into battery-grade lithium carbonate or lithium hydroxide before it can become a cell. China controls around 80% of global lithium processing capacity. So even when the mine is outside China, the battery material can still pass through Chinese factories. China's control also reaches other key battery materials. It handles about 65% of global cobalt refining, more than 70% of the graphite anode market, and a major share of rare earth magnets used in EV motors. Each one can be replaced over time, but replacing all of them together is a massive job. New mines, refineries, and processing plants can take 8 to 12 years to build at scale. BYD's factory strategy shows how tariffs can be bypassed. The company is building plants in Hungary, Brazil, Mexico, and Thailand. Cars assembled there can qualify as local production, but the battery cells, processed lithium, cobalt, and graphite, can still come from Chinese supply chains. A tariff may block a Chinese badge at the border, but it cannot easily block Chinese content inside the car. America's IRA rules try to bring battery production closer to the US, but the timing is difficult. Building a full domestic supply chain can take 8 to 12 years, while BYD's solid-state target is 2027. China built much of this supply chain between 2009 and 2020. The West is now trying to rebuild in a race where the most important materials path is already controlled. Global market damage is already showing in company numbers. Volkswagen, after 87 years, has warned about possible German factory closures and up to 35,000 job cuts. Ford's EV division lost about $4.5 billion in 2023, close to $3,000 per EV sold. GM delayed EV targets more than once, and Stellantis warned that Chinese competition was hurting margins. Chinese EV brands are already taking ground in markets with less protection. In Southeast Asia, they captured more than 60% of EV sales in 2023. The BYD Atto 3 has beaten major rivals in markets like Thailand, Vietnam, Indonesia, and Brazil. These countries are not side markets. They are fast-growing car markets where millions of new buyers are choosing their first EV brand. Western suppliers are also feeling the hit. When Volkswagen, Ford, or GM build fewer cars, their suppliers lose orders too. Companies like Bosch, Continental, Magna, and Aptiv depend on Western production volume. In 2023, Bosch announced around 1,500 automotive job cuts, while Continental announced restructuring affecting about 7,000 employees. The pressure moves from automakers into the whole supply chain. Tariffs protect showrooms, not the full industry. The US placed a 100% tariff on Chinese EVs, while the EU added tariffs of around 17% to 38%. These rules can slow Chinese-branded cars from entering some markets. But many Western EVs still depend on battery cells, minerals, or materials linked to CATL, LG, and Chinese processing chains. Blocking the badge does not remove the dependency inside the vehicle. Solid-state batteries could speed up a shift already underway. Chinese brands are building customers, dealers, service networks, and trust before the next battery generation fully arrives. Once buyers in Asia, Europe, and Latin America are already driving Chinese EVs, switching them back becomes harder. Solid state does not start the market destruction. It gives China a stronger weapon after the first wave has already landed. A huge shift could hit the car industry if BYD reaches solid-state mass production by 2027. That date matters because many Western companies are still struggling to fully compete in today's EV market. If China launches next-generation batteries while rivals are still fixing current EV problems, the industry moves into a new era before many automakers finish adapting to the last one. Manufacturing scale remains the biggest challenge. Toyota spent more than 15 years trying to solve large-scale solid-state production and still delayed its targets multiple times. BYD is taking a different path. Pilot production lines are already running, producing real battery cells under factory conditions. Every batch gives engineers more data about heat, durability, speed, and cost. Research in a lab matters, but factory learning matters more when millions of batteries are involved. Consumer behavior could change very quickly once solid-state EVs arrive at scale. A range close to 1,000 kilometers removes range anxiety for most drivers. Charging close to 10 minutes makes EV charging feel much closer to refueling a petrol car. Improved battery safety also matters for insurance companies, delivery fleets, taxis, and commercial transport businesses that worry about fire risks and downtime. Western automakers face more than a battery problem. China already spent years building supply chains, battery factories, refining systems, and vertically integrated production. Companies like CATL and BYD control huge parts of battery manufacturing, while China also dominates processing. For materials like lithium, graphite, and cobalt, these advantages cannot be replaced in a normal 3 or 4 year vehicle cycle because industrial infrastructure takes decades to build. The car industry after 2027 may look very different from the one that existed through most of the 20th century. Western brands like Ford, GM, Volkswagen, and Toyota will still exist, but the center of battery technology and EV manufacturing could sit much more heavily in China. Decisions made in Beijing after 2009, combined with slower EV transitions in parts of the West, may end up reshaping who leads the global automotive industry for the next generation. China didn't just enter the EV race, it rebuilt the road itself, and now the entire global auto industry is chasing it.